So now we know the basics. So x plus 1 and 1 plus x, these are same. So no need to complicate this one again. X minus 1, here I am having my 1 minus x. Both of the directions were changed. No, positive x became negative x. Negative 1 became positive 1. So in this case, you can bring minus 1 as a common factor to write it as x minus 1. You are having x minus 1 and x plus 1. These are not same with each other. Somehow you have to include both of them in your LCM. That's what we are going to discuss hereafter. So look at the question. In the first question, I'm having p minus 4. P minus 4, comma, 8 minus 2p. 8 minus 2p. These are the values I have to find the LCM for. First of all, I will write the p minus 4 as it is. There is nothing else to factorize furthermore. So we can write p minus 4 as it is. But look at the second one. 8 minus 2p. Here I can select 2 as a common factor. After selecting 2, we will have 4 minus p. 4 minus p. Now look at this. Both of the brackets are having uh, expressions are having p and 4. But both of their directions were changed. So in this case, what you have to do? P minus 4 remains same. In here, you have to bring minus 1 as a common factor. So positive 4 divided by negative 1, that will become negative 4. Negative p divided by negative 1, that will become p. So p minus 4. It will become 2 times negative 1. Negative 2 times p minus 4. This would be the factorization we have to incorporate while we need to find the LCM. I'll repeat again. After selecting 2 as a common factor, 4 minus p is there. So both p and 4 are having different direction. We can make them as same while selecting negative 1 as a common factor. That's what I did here. Thereafter, these numbers are just multiplication in multiplication relationship. 2 times negative 1, it would be negative 2 times p minus 4. While writing the LCM, look at this. It does not have any coefficient. That means the number before the there is no any common factor here. But here it has a common factor as negative 2. I will write that. Since both are having p minus 4 expression, that should be included in our answer, p minus 4. So this would be the LCM for the first question. Likewise, we will try another question as well. So here we will incorporate them with a square, comma 2 times a minus b, comma b minus a. Here we are going to find the LCM. A square is already in the ground set. So 2 times a minus b. This one also already factorized. So a square and 2 times a minus b still remains same as it is. But look at the next one. Both a positive a became negative a here, negative b became positive b here. So what you have to do, as we already know from the previous explanations, you have to select negative 1 as a common factor. Thereafter, from negative a, when you select negative 1 as a common factor, it will become a. Positive b divided by negative 1, it would be negative b. Then let's come to the LCM part. First, I can write 2 times negative 1. So when you find the LCM for them, it would be negative 2. And thereafter, only A related. These are not A related values, okay? Not A related indices. These are some expressions. Those are also having A quantities, but don't confuse with that one. This A square is a separate quantity. This expression is a totally separate one. So in A quantities, we are having A square. Negative 2 times a square. Thereafter, we are having the expression. What's that expression? A minus b. A minus b. So this would be the answer for our question. So negative 2, that is the numerical LCM. in A indices, A square in expressions, A minus B. That would be the answer for our LCM. So in the first question, 3 times x minus 2 that is already in factorized form. We will keep that x minus 2 as it is. Thereafter look at the next one. Here the next value which we are having, that is having 2 minus x. The positive x became negative x here, and negative 2 became positive 2. So this is kind of a negative factorization. So in this you have to select negative 1 as a one factor. Thereafter you can write it as x minus 2. Nothing will be changed for this one because look at the first quantity. It does not have any x minus 3 or 3 minus x quantities. No. So no need to change that one. This one still remains same as it is in the expression. We have to convert only the x minus 2. 2 minus x, by taking negative 1 as a common factor, we converted 2 minus x to x minus 2 form. Thereafter, we will find the LCM. You have to find the LCM for the numbers 3 and negative 1. It would be negative 3. In both x minus 2, there is an expression. Thereafter, another expression would be 3 minus x. So, all these three included in our LCM. Negative 3 times x minus 2 times 3 minus x. In the second question, look at this. This is not like the previous question which we've completed. Here, both two are having positive direction. This is positive, positive. Only one direction is changing. Look at this. If 2 minus n, if there is any x minus 2 here, you can directly convert them by taking minus 1 as a common factor. Look at here. Both two are having same direction in both cases. Only direction of x is changed. So this cannot be the one which we've discussed under previous instance. So here LCM would be, you have to include the number. That number is 4. Thereafter this is a separate one, this is a separate one. You have to understand that clearly. Here both are different direction. Here both are same direction. So in these cases we cannot make them as same. So you have to incorporate both of them into your answer. So minus x and 2 plus x both should be included in your answer. That would be the LCM. Look at the next question. So if I told you that e minus 1 means that t is already in the ground state. 1 minus t and square. So I can write this 1 minus t square as, look at this. If you are having square, this is the way you have to follow. 1 minus t times 1 minus t. X square means I can write it as x times x. No. Likewise, 1 minus t square means 1 minus t into 1 minus t. T minus 1, that is in the standard form. I have to make t positive, t negative, 1 negative, 1 positive. Both directions are changed. No. So, you have to select negative 1 here in the first expression to make it as 2t minus 1. Okay, make it as t minus 1. Look at the next expression. This is also similar like the previous one. Positive t, negative 1, positive 1. So here also we can select negative 1 as a common factor to write t minus 1. I'll repeat again. This is total square. Square means you can express that one as 1 minus t times 1 minus t. So in 1 minus t, to make it as t minus 1, you have to select negative 1 as a common factor here. That's what we did here. Again also we are having another participant with 1 minus t. Here also you have to select negative 1 as a common factor. Thereafter I'll write t minus 1. Look at this. This is multiplication. We can do that one. Negative 1 multiplied with negative 1, that will become positive 1. T minus 1 multiplied by t minus 1, it will become t minus 1 square. T minus 1 square. Because this negative 1 multiplied by negative 1 will become positive 1. So no need to indicate the positive 1 here. We know that there is no any coefficient given. We know there is a positive 1 there. Likewise, no need to indicate that. Negative into negative positive, 1 ones are 1. That would be the one here. T minus 1 multiplied with t minus 1, it would be t minus 1 whole square. So LCM, there is no any numbers. Since there is no any numbers in the expression, this is t minus 1. Here also t minus 1, this is having the higher power. So you have to include e minus 1 square as your LCM for the question. So in the question in right hand side, 5 2x minus, that is already factorized and in the ground stat. To get the next one, positive 2x became negative 2x, negative 1 became positive 1. Both directions were changed. So I'm going to write 1 minus 2x as 1 minus 2x times 1 minus 2x again. In both cases, I will select negative 1 as a common factor, 2x minus 1, again also multiplied by negative 1 times negative 1 times 2x minus 1. Okay. Thereafter, look at these two, this one and this one. LCM for the numbers, it would be negative 5. Here it is, we can write this one as negative 1 times 2x minus 1 whole square. Sorry, not negative 1. Sorry. Negative 1 multiplied by negative 1, it will become positive 1. Okay, it will become positive 1. So no need to indicate the positive 1. Then negative 2x minus 1 multiplied by 2x minus 1 to become 2x minus 1 whole square. So here in this case, we will write that one 5. 5 is the numerical common factor, and in the bases 2x minus 1, here 2x minus 1 whole square. So that would be the answer. 5 times 2x minus 1 whole square. So first of all, in the first component, we will select 2 as a common factor. 2 times a minus 2. We can write like this. In the second component, that is already in the factorized set. So no need to convert that again. You can write this one as it is. Thereafter, look at the third one. 8 times a plus 2. There is no any other a plus 2. We can keep it as it is. Look at this. 2 minus 1 a whole square. That means with respect to other two, these are having a minus 2. There we are having, in the last one, we are 2 minus a. Positive a became negative a, and here negative 2 became positive 2. So as usually you have to select. I will do this one here. Negative, we can express this one as the expansion. 2 minus a times another 2 minus a. Thereafter, 8 times a plus 2, that remains same. From 2 minus a, I will select negative 1 as a common factor. So what will happen? 2 minus a will become a minus 2. In the second component also 2 minus a, select negative 1 as a common factor and write rest of it as a minus 2. Okay, we have completed our work. Thereafter, in next one, 8 times a minus 2, sorry, a plus 2, negative 1 multiplied by negative 1, that will become positive 1. No need to indicate that one. Since it is a multiplication, have to multiply that one with 8. Now we will write 1 time negative 1 multiplied by another negative 1, positive 1, a minus 2 times a minus 2, it is a minus 2 whole square. Finally, 8 times 8 multiplied by 1, 8. Here we are having a plus 2 and next a minus 2 whole square. That's all, nothing else. So let's carefully find the LCM for the numbers for 2, 12 and 8. You can use number 2 first. 2, 6 and 4. Again also we can use number 2. 1, 3, 2. Again also we can use number 2. 1, 3, 1. Finally we can use number 3. 1, 1, 1. So LCM for the numericals, it would be 2, 2, 2, 8. 2 times 2, 4. 4 times 2, 8. 8 times 3, it is 24. Look at the bases. A minus 2, a minus 2 square. Here also a minus 2 square. A minus 2, the square is the higher position. A minus 2 square. Other than that, a plus 2, we are having another base. A plus 2. You can write your answer like this. If not, you can write in another method as well. You can change this order. 24 a plus 2 times A minus 2. Yeah, both are correct because look at the stats. A plus 2 in its singular state. That means in ground state there is no any indices. Here also A minus 2 also in its highest form, square form. Both cases likewise. You can write your answer like this, either this one or this one. Both are correct.